So we are week two, and first of all, I'm going to talk about the preparation that we had before starting the project. So we created a common email account which everyone could access. We also made a Tumblr page. We made lots of researches for our experiment, and we also had a common group chat. So this is our common group chat, which is very efficient, because we all know that Facebook is very, very popular nowadays, so everyone uses it quite often. This is also our common email, which is, in my opinion, quite a good idea, because we could send each other files, which made our whole process very efficient. So basically our goal for the whole project is to investigate the natural condition of zinc, copper, and aluminum. Also, we investigated the biological, physical, chemical properties of metal corrosion. We'll hear much more about this. So this is a picture of us while we're working hard. Yeah. We also have a link. Can someone open it from the computer, please? A Tumblr page that's the link actually.
Press control.
Press control and then press the link. So I'm not very into Tumblr, but I think it's also a really good idea because other people can watch our site and get ideas from our project. Can you scroll down a bit further now? So we uploaded all the pictures. We also have some comments, programs. Stages that we have went through from starting all the way to our result. Okay, and now we're going to talk about the project itself.
Yeah, so about the project. Basically, corrosion is the gradual destruction of materials, usually metals, by chemical reaction with their environment. And this natural process converts refined metals into their oxide, which are usually more stable than the element itself, which makes this process spontaneous, as all elements try to achieve stability through different methods, for example, forming compounds. And corrosion is a global problem that causes a lot of damage worth millions of dollars each year, and it is a really important aspect to think about when planning a construction of a new building. So our goals were to confirm the corrosive effects, to check the durability of these different metals, and discuss the effects of corrosion on the human body, and also to try to find a solution for this problem. More specifically, our objectives were to compare and demonstrate the corrosive effects of water and salt water at different temperatures on aluminium, zinc, and copper, and to demonstrate the effects of acid rain on these three metals. And we stimulated this by the use of sulfuric acid and nitric acid. And we also wanted to inform about the biological effects of corrosion, and finally to give a practical solution to this problem.
Okay, so the first experiment, we took 3 different types of metals, zinc, copper, and aluminum, and we put them in a saltwater bath in beakers, and we had 4 samples of each type of metal. And then in the beakers in the saltwater bath, we put those in hot water, and we left it overnight for 12 or 15 hours, and then we measured the weight of metals before we put them in the salt water, and then after we put them in the salt water to measure the rate of corrosion.
Yeah, we also tested the effects of nitric acid and sulfuric acid, which is commonly known as acid rain. So we left that overnight as well, and we have all of the results on that table there if you'd like to look at them. I don't know. Yeah.
And these are the results. If they're not clear enough, you feel free to go there and check the results yourself. You can do it right now.
No.
All right. Okay, so I'll be explaining a little bit about the results. So first we can see that the sample of copper, the first sample is water at room temperature. The second sample is copper plus, second sample of copper is water plus salt at room temperature. And the third sample is water at 50 degrees Celsius. We use the water bath. And the fourth one is water plus salt at 50 degrees. And that's the same for all the elements down there. So the first change, we didn't observe any change for the first sample of copper 1. But we do see a difference in the weight before and after, because it gained weight. And for the second sample, we saw a green residue. And I'll be explaining this later. So here again, we can see a difference in the weight before and after. So for this third sample of copper, there was a red layer on top, which signifies that there's corrosion. And again, we can see weight change. So for the last sample of copper, you can see that the water is greenish and the metal turns some green marks. This again is the same effect as the second sample, and I'll be explaining it in the latest study. So for aluminium, the first sample of aluminium, we observe no change. And this is due to the effect that there's an oxidized layer on top of aluminium, so it does not react with water at room temperature. And it's the same with water plus salt at room temperature. And aluminium, the third sample of aluminium is water at 50 degrees. And we can see some speckles, some little bubble marks on it. This shows that some reaction did occur. And at sample 4, we see a golden tint on the aluminium. Then finally, the last element, that's zinc. So the first sample of zinc, we don't see any change there. And the second sample, the zinc turned a bit darker, but we're not sure if the metal was like that before the experiment. So, and the the third sample of zinc, we can see the partial color darkened. Here again, we are not sure if the color was the same before the experiment. And the last sample of zinc is water plus salt at 50 degrees, and here again the color darkened with white residue in the water, which could be the salt, undissolved salt. About the green residue on copper. Green residue deposit of copper is called verdigris, and this is formed when acetic acid is added to copper or any alloy of copper, or if it's exposed to air or sea. So here we're not sure what kind of compound copper formed, so we had to deduce it. So first, the green residue is usually copper carbonate, and in the case of acetic acid, it's copper to acetate. But in this case, we use salt water, and when copper reacts with, this is the reaction here, salt water, it forms copper chloride, and this is the verdigris that we observed in our samples. And this is the experiment 2. Here's the setup, and if you want to look at the setup, it's right there. Just in case this isn't clear enough. And so, sulfuric acid. For sulfuric acid, we tested copper, aluminium, and zinc. And for nitric acid, we again did the same. And here are the results for the experiment. So first, for copper, we observed no reaction with sulfuric acid. But the nitric acid, we did observe a reaction where copper reacted with nitric acid to form a greenish blue solution. And I'll be explaining that in the later slide. So for zinc, we did see reactions. We did see bubbles, which indicate a reaction. And same for nitric acid, we observed a reaction due to the bubbles formed. And aluminium, again, we observed reactions due to the bubbles. So I'd like to,
Why can't you just throw it properly? Why can't you just throw it properly?
Okay, cheers guys.
Alright, so to explain the reaction between copper and nitric acid. So here copper, this is the basic formula for the reaction. That's copper plus nitric acid. It gives us copper nitrate plus 2 NO2, that's nitrogen, nitrogen dioxide, and H2O. That's copper. So here, copper nitrate, it's brownish, red. But when, because this citric acid had some water with it, the reaction goes like this: 3Cu plus H and O, 3. There's 3Cu and 3, 2. And this compound right here, this causes the blue color in the solution that we observed. And now I'll hand it to Parmis to explain the biological effects of corrosion.
Well, there's not much to it, but it's clearly like harmful to the body. It can burn your skin. It can affect your eyes as well. If you inhale them, you can get residue in your lungs, which is not great. Hold on. Yeah, they can burn the inner linings of your nose and burn your lungs as well. Yeah. They're also very flammable and combustible, so be careful, don't light anything around them. So you gotta just stay away from corrosive metals. Yeah, there you go.